Hello there. Welcome to Astraveo's continuing education series, where for our podcast listeners, we talk about mathematics, the physical sciences, of course the natural world, and our personal favourites, astronomy. Now, you know Joseph and I are all up in and about astronomy. We get super excited about that stuff. So let's get going. Welcome back to Astraveo's continuing education series. And this evening we're going to be talking about trigonometry, or the science of angles. Now this is just an introduction. I'm going to keep it fairly simple, but there's a really nice couple of demonstrations that we can do. So let's get started. So this is almost always based with triangles. And so trigonometry deals with how to figure out angles specifically. So this is a really nice way to start is with a right angle triangle. Let's call it A, B, C. And here is just a nice angle. And then we tend to call, I think we discussed in the last episode, that many angles in mathematics are normally Greek letters. Of course, a lot of the early mathematical work was done by the Greeks. So we tend to use theta. Now we need to have a couple of definitions here. The side opposite an angle is called, quite naturally, the opposite. The side that is the longest side in a right angle triangle, we already know, is called the hypotenuse. And this angle happens to be adjacent to the 90-degree angle, so it is called the adjacent. Now we have a couple of formal definitions. We'll just do the basics. We just have three. We have sine of theta. Now it's normally written as sin, but it's actually with an E. So it's like this. So sine of theta equals the opposite, I've got to make sure I remember myself here, the opposite divided by the hypotenuse. The cosine of theta is the adjacent divided by the hypotenuse. And finally, the tangent of theta, is the opposite divided by the adjacent. Now, I've been using uppercase letters. Let's keep that. Let's make sure we get this the same. A. Now, the way it's normally written, tangent is written as tan, cosine is written as whoops, didn't get that quite right, did I? Is written as cos, and sine is written as sine, S-I-N. Now, you may be able to see a relationship here, and this is how an awful lot of school children have been taught this for generations. It's not just for my generation. S for sine, O for opposite, H for hypotenuse. So, C for cosine, A for adjacent, H for hypotenuse. K. And tangent is opposite over adjacent, T-O-A. And it's colloquially, familiarly called SOHCAHTOA. SOHCAHTOA. That's how you remember, that's how I remember it. And millions of students across the world, that's how I think they remember it. So sine is opposite over hypotenuse, so. Cosine is adjacent over hypotenuse, K. And tangent is opposite over adjacent. Okay, so that really is the basics. It's really quite simple. So I'm going to get rid of this. That's all we have to remember. SOHCAHTOA, and we're in business. Let's give ourselves an example triangle. And you're going to see that it's going to work out really, really nicely. Give ourselves a right angle again. This time I'm going to give us a 30-degree angle. A, B, C. Now, if you have a 30-degree right angle triangle, we might want to know what are the lengths of the sides. Now, I happen to know that the sine of 30 degrees is a half. So that gives us a great starting point. The sine of 30 degrees, previously it was theta, but we've been given it this time. Theta equals 30 degrees. The sine of 30 degrees is 1/2. Well, we know that sine is opposite over hypotenuse. So the side opposite the angle is 1, and the hypotenuse must be 2. Well, we have a right angle triangle, so we can do a little bit of Pythag here. I'm going to draw it up here a little bit smaller. We have 1, 2, and we don't know this side. And Pythagoras says the sum of the squares, the two shortest sides of a right angle triangle, equals the square of the hypotenuse, the longest side. So we have 1 plus question mark squared equals 4. Subtract 1 from both sides, we get question mark squared equals 3. Question mark equals plus or minus 3. Take the square root. Well, we can't have a negative distance. We know that square root. We know that that side must be root 3. Root 3. So now we can work out the cosine of 30 and the tangent of 30. So if the sine of 30 degrees is a half, the cosine of 30 degrees, cosine is adjacent divided by hypotenuse. Here's the adjacent side, the side of for the angle adjacent to the 90 degrees. So the adjacent is square root of 3, the hypotenuse is 2. The tangent of 30 degrees, tan 30, equals opposite divided by adjacent. Opposite is 1, 1 divided by square root of 3. So just from knowing one angle, we were able to work out the lengths of the sides of a right angle triangle. Turns out to be really useful in all kinds of fields, from agriculture to architecture to mathematics, of course, science, engineering, astronomy, definitely. So this is a really fundamental set of mathematical constructs. The trigonometry, the way we deal with angles, trig is to angles, metry is to measure. Measuring angles really helps us understand right angle triangles especially. It's really good. So we have 3 definitions. Sine, opposite divided by hypotenuse. Cosine, adjacent divided by hypotenuse. And tangent is opposite divided by adjacent. Now, I promised my daughter Charlotte that I would show you a trick. And I texted her this evening, and she actually reminded me of the name, the nomenclature. So we know sine. Sine. Oh dear, that's not so good. Sine is opposite over hypotenuse. Cosine is adjacent, so ka over hypotenuse. Now we know TOA is opposite over adjacent, but tangent, we have a special definition for tangent. I've been a bit naughty here. I should put the angle in as well. It's just a little bit lazy. Okay, tangent is also sine theta divided by cosine theta. That's a formal definition. Excuse me. So it does happen to be opposite over adjacent, but can we prove that? Well, yes, we can. Excuse me. We know that sine theta is opposite divided by hypotenuse. So it's opposite divided by hypotenuse. Cosine theta is adjacent divided by hypotenuse. Adjacent divided by hypotenuse. And this is where Charlotte comes in. Because I'm reasonably decent at dividing fractions out, but the way they're taught these days, especially in the United States, possibly Western Europe, I'm not sure, is in order to deal with division of fractions, which can be complicated, is in the olden days we were told just to flip the second fraction and then you can cross multiply. Well, here it's called change, keep, flip. I think, yes. Let me make sure what Charlotte said to me tonight. Keep, change, flip. Wrong way around. Keep, change, flip. She'll tell me off later. So what that really means is tan theta is you keep the first fraction, opposite divided by hypotenuse. That's what it is. You change the divided by into a multiplication, and you flip the second fraction. So instead of adjacent over hypotenuse, it becomes hypotenuse over adjacent. Okay, and let's make sure we get this right. Keep the first one. Change the mathematical operator. Flip the second fraction. Keep, change, flip. Ah, there you go. So what she told me was really good. Okay, hypotenuse divided by hypotenuse, that cancels. Then you're left with the tan of theta is opposite divided by adjacent. Tangent is opposite divided by adjacent. So that's really nice. Apart from using SOHCAHTOA, if you're not sure about tangent, it's just the sine divided by the cosine. Okay, so that's a really nice set of examples right there. Welcome to trigonometry. Thank you for watching.